This video will discuss how to determine the correct reorder point and safety stock level. In this problem, we have a business whose average lead time is 5 days, with a standard deviation of lead time of 1 day. We also have the fact that their average daily demand is 150, and that this daily demand has a standard deviation of 16. We need to convert the mean and standard deviation of daily demand and the mean and standard deviation of lead time into a mean and standard deviation of demand during lead time. The mean of demand during lead time is simply the average lead time times the average daily demand. The standard deviation of demand during lead time involves all 4 of the initial assumptions. The formula is shown to the right. The small Greek letter sigma is a common notation for standard deviation, with the D referring to daily demand and the LT referring to lead time. So we just need to enter this formula very carefully. The square root of the average lead time times the standard deviation of daily demand squared plus the average daily demand squared times the standard deviation of lead time squared. You notice in this formula that the average lead time in cell B2 is the only value that's not squared, and this is actually the correct formula. So the standard deviation is about 154. Just to get an idea of the range of values that we might expect to see during lead time, we could calculate the minimum and maximum. We're going to assume a normal distribution for demand during lead time. And in a normal distribution, nearly all the values are within 3 standard deviations of the mean. So the minimum value for demand during lead time that we would expect to probably see would be the mean, 750, minus 3 times the standard deviation, about 287. The maximum that we would expect to see would be the mean plus 3 times the standard deviation. While it's possible to have a value below this minimum or above this maximum, this gives us a reasonable range just so we simply understand how much demand during the lead time period can vary. Initially, we'll specify a desired service level. Let's say 95%. What the desired service level means is that when we place an order, we want there to be a 95% probability that we will not run out of inventory before we get our new shipment. The thing that makes this difficult is that we might have demand of as little as 287 or as much as 1213 while we're waiting on our new shipment of inventory. We need to set the reorder point high enough that there's a fairly small likelihood of running out of inventory before we get the next shipment. We can use a normal distribution formula to find this reorder point. The formula is called norm.inv, the inverse of the normal distribution. The probability that we're specifying is 95%. The mean of our normal distribution is the mean of demand during lead time, and the standard deviation is the standard deviation of demand during lead time. This gives us a reorder point of 1003. So when inventory reaches that level, we would make our next order, and that would give us a 95% chance of meeting all the customer demand during that lead time period. The safety stock is simply the reorder point minus the mean demand during lead time. Safety stock is an extra layer of inventory that we keep around the majority of all of the year on average to buffer against stockouts. In this case, it's 253. There'll be times when we build up the safety stock. There'll be other times when we use the safety stock in higher than usual demand periods. But on average, we expect to have around 253 units of extra inventory, and this will affect our holding